Alright, what is good, class? Welcome to our first day of distance learning. I think it's going to be fun. Let's see. Hopefully y'all did alright with that chapter 8 stuff. But today we're going to move into chapter 9. If you have graph paper, I would suggest using it. And you'll realize quickly that this is not the method you want to use later on once we learn more techniques, but for now you gotta learn it. There'll be a few ways to solve these problems, but you need to know all of them. So basically we're gonna have two lines and we're gonna have to see where do they intersect. And today we're going to be graphing them and seeing where they intersect. There will be some instances where they are the same line. Obviously, if they're the same line, where they intersect is everywhere, so there'll be infinitely many solutions. And there will be some where if the lines are parallel, obviously they never intersect, so there'll be no solution for those types of equations. So, my verbiage might be a little bit different in the book, but solution in this chapter, or where this section is, where two equations intersect. That's essentially what's it gonna be. You'll see the verbiage a little bit different in the book, and you should know those. But for now, we'll stick with that definition. So you'll see the book, let's see if the black pen works, gives us two equations to begin with. 2x minus y equals 8, and x plus y equals 1. Equation 1, equation 2. The first step you're going to want to do, you are going to want to put these into slope-intercept form. That is y equals mx plus b form. So, for equation 1, I'm going to move the 2x to the other side. And then I'm going to have to divide by a negative to get positive y. So it's going to be 2x minus 8. That is in slope-intercept form for equation 1. Equation 2, I'm going to have to move this x to the other side. So I'm going to have y equals negative x plus 1, and that one is in slope-intercept form as it stands. The only other thing to do is to graph them and see where do these intersect. Oh boy. Do I have enough room for 8? Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Let's see. Let's see if I get lucky with this graph. And you should notice that these two equations have different slopes. And if you have different slopes, you will intersect at some point. So we are going to be guaranteed an intersection. So let's start with equation 1. First, graph the y-intercept. So negative 1, 2, 3, 4, 5, 6, 7, 8. Where there's a slope of positive 2, that means rise 2 over 1. Rise 2 over 1. Rise 2 over 1, rise 2 over 1, and I just do a ton of these. And connect it with a straight line. It would be best to use a ruler, but what you gonna do? And equation 2, y-intercept is 1, so I'm going to go up to 1, and this has a slope. It doesn't have anything in front of it, so if you don't have it, you have an imaginary 1. So it's an imaginary 1 over 1, which means go down 1, over 1, down 1, over 1, down 1, over 1. Oh, look. There's a purple dot right there. If you get to that point where they intersect, you don't need to make any more dots. You can go ahead and stop there. So I am going to draw this line. For the most part with graphing, they should hopefully be nice and be whole numbers. Later on in the future sections, you may not get whole numbers, but for graphing, hopefully they'll be nice and give us whole numbers at intersections. So let's see, where is that coordinate? 1, 2, 3, 1, 2. So 3, -2 is your solution. It's as easy as that. This will be easier if you do it on graph paper, however. So let's put that down. Let's try another one. So you'll see the book gives another example. X minus 2y is -6. X minus 2y is 2. Now this is a simple one. You can see, these look kind of the same. These look a little bit different. So, again, like I said, you want to put things in slope-intercept form. So, I'm going to have to move the x over from this top equation. I'll have -2y equals -x minus 6. Then divide by -2 to get y equals. Negative divided by a negative is positive. So 1/2 x, -6 divided by -2, +3. And let's put the second equation in slope-intercept form. Subtract x, so I'll have -2y equals -x plus 2. Divide by -2, so y will be 1/2 x minus 1. So you see, same slope, 1/2, different y-intercept, +3, -1. So you should tell by looking at this, these lines are not going to intersect, ever, never ever. So you should already be expecting them not to intersect, which means there will be no solution, but we're in the super lame, boring graphing method section. So we gotta graph it, and then be like, there's no solution, because they never intersect. And again, graph paper will be your friend. And these ones aren't too crazy right now. If you think it would be beneficial to you to use different colors, like I am, by all means. However, I'm still not a fan of using pen, even though it's kind of, you're not really able to do that here unless you use colored pencils, which aren't really that easy to erase anyways. So slope is 1/2, which means rise 1 over 2. And connect with a straight line. Maybe a little bit better than mine. And then this one has a y-intercept of -1. So I go down to -1. I then go up 1 over 2, up 1 over 2, down 1 over 2, down 1 over... Counting is hard. And you look at those and you're like, I don't think these are going to intersect. And you'd be right. So what do you say? You say no solution. Because remember, solutions are where they intersect. And these are never going to intersect, so there's no solution. And the last type of one, you've guessed it, we've already had intersecting. Now we had not intersecting. Now you're going to have intersections everywhere. Everywhere. Which means there'll be infinitely many solutions. So, 2x plus 3y is 6. 4x plus 6y is 12. Now, sometimes they're easy to see like this one. Sometimes they're shifted over a little bit, and so it's not as easy to see right away. But you might be able to see, that's double. This is double. This is double. All the signs are the same. That's kind of a sign that these two equations will be the exact same thing, which means they're going to be the same line, which means there's infinitely many solutions because they're stacked on top of each other. But it's graphing method, so we have to do it the graphing way. So, I'm just rewriting it because I'm using marker and I messed up. So, I'm going to subtract 2x. We have 2x plus 6 divided by 3. Y is negative 2/3 x plus 2. Coolio. Equation 2. I copied it out the first time, so I'll keep that trend going. Subtract 4x. So 6y is negative 4x plus 12. Divide by 6. Negative 4 over 6x plus 12 divided by 6 is 2. Now you see here that negative 4 over 6 can be reduced. So that's negative 2/3 x plus 2. They're the same line. I wonder what's gonna happen. Where are they gonna intersect? Bam, 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 bam. Doo, 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 doo. Don't need too many lines for this one because we're smart and we know where they're gonna intersect. So, purple, y-intercept of 2, slope negative 2/3, so go down 2 over 1, 2, 3. Remember, you want to make sure you're having a negative slope. If I want to go up 2, left 1, 2, 3. And that'll be good enough. And playing dumb, you're like, okay, gotta graph this second one, gotta see what's gonna happen. Up 2, oh, the same dot. Alright, I better see the slope where it goes. Down 2 over 1, 2, 3. Oh, that's the same thing. Up 2 over 1, 2, 3. Oh, same thing. They appear to land and intersect everywhere. It's because they do. So, you can write the word infinitely many solutions, or you can write that was terrible in the infinity sign, but infinitely many solutions. They intersect everywhere. And that's about it. Just the steps to make sure you're doing. Put things in slope-intercept form. Graph the y-intercept. Use the slope to make multiple points. Don't just do 2 points. Put a bunch of points that you'll see later where are they going to intersect. And you'll see they'll get a little bit more complicated in some of the graphs. They'll have u's, which we learned were parabolas. Again, solutions, where do they intersect? If they intersect in more than one spot, you have more than one solution. That's about it. I'll see y'all later.